Hello. Thank you for joining the Texas Instruments new Products Update webinar. Just a reminder that this is a weekly series every Thursday at 10 a.m. Central. A few quick announcements before we get started. This webinar will be recorded and available online at ti.com/NPU. All phone lines will be muted, so if you have questions, please use the chat box and we will try to answer in real time, or you can contact your TI salesperson or field application engineer. Today's topic is Boost Signal Integrity with PCI-SIG certified PCIe 5.0 redrivers. I will now pass it over to Connie Liu for introductions.
Thanks, Kelly. Can you hear me okay?
Yes, can hear you great.
Sounds good. Good morning, everyone. My name is Connie Liu. I'm the product marketing engineer under our high-speed signal conditioning team, and I focus specifically with PCIe interface.
Hello, good morning, good evening. I am Anwar Sadat, and I am a lead product definer working for different components in different interfaces, including PCI Express.
And I'll go ahead and kick off this presentation and hand it over to Anwar later in the presentation with our Boost Signal Integrity with PCIe-SIG Certified Redriver Gen 5. And this is a quick overview of our agenda. I'll dive into a little bit high level of our portfolio for PCIe signal conditioning solutions, as well as the key features on these PCIe-SIG certified Gen 5 redriver, as well as the performance, followed by how we do compliance and interoperability testing for all of our devices. So we are part of a product line called High Speed Signal Conditioning Team, HSSC. And our goal of a product line is to help improve your signal integrity on your high-speed data line, whether that is Ethernet protocol, PCIe protocol, USB, or video such as SDI, HDMI. We have a portfolio of retimer, redriver, and muxes to help boost your signal and provide signal routing to help you pass your compliance testing that's needed for your specific protocol. And today's presentation, we will focus only on the PCIe segment of the high-speed signal. So there are three main types of PCIe signal conditioning solutions that we have between retimer, redriver, and mux. The first one on the left is retimer. A retimer have a digital control loop that samples the incoming data and copies a clean set of data and regenerates the output. So it provides the maximum reach extension by resetting the complete jitter budget, as well as clean up any reflection and the channel loss. And it does provide diagnostics that allow you to understand the handshaking between the root complex and the endpoint or the receiver. And retimer does participate in the protocol training. And because of the complexity of retimer and providing a maximum reach extension, it does come with a higher power as well as higher costs associated with retimer. The second solution is redriver. A redriver is an analog device that simply boosts the high frequency signal of your data. And so it's a very low latency device as well as low power. It does provide a medium reach extension for channels that does not suffer too much jitter because it cleans up channel loss and does not support cleaning up of the jitter. And it is a very simple to use device. There's no need for any reference clock for redriver. Redriver acts as a transparent device between your root complex and endpoint. So it is a protocol agnostic device. So if you have a same physical connections as PCIe, it can support different types of protocol like CXL, UPI, or SAS or SATA. You can all use redriver for the same physical connection to boost your signal. And the last category is MUX, where in applications you have PCIe constrained slots. You have multiple root complex and one endpoint, or you have one endpoint but multiple endpoints. You can do signal routing with this MUX. We do have portfolio that have MUX with built-in redriver. So along with signal routing, it provides boosting of your signal as well. And here is our PCIe roadmap. On the left-hand side, we have our Gen 4 portfolio. On the right-hand side, we have our Gen 5 portfolio. We do have different offerings that have different configurations from 4-channel all the way up to 8-lane. 1 lane is 2-channel, but bidirectional communication, and then channels are defined by unidirectional communication. And for today's presentation, we'll focus on our newest release family of devices, the Gen 5 portfolio. They do use the same IP and have the same similar performance on these family of devices. So we have DS320PR810 that supports 8-channel at Gen 5 speed, along with MUX and DMUX and Crosspoint with the built-in redriver functionality. And we do have other offerings in our roadmap as well. Feel free to reach out to us or to your local sales contact to learn more about our other portfolio and future roadmap for our PCIe offerings. And with that, I will hand it over to Anwar to go over our PCIe Gen 5 redriver performance.
Thank you, Connie. So what we have in this particular slide, some simplistic block diagram on the top right. One is DS320PR810, which is a redriver. This is an 8-channel redriver. That signals, takes signals from one side of the device and provide boost functionality and provides to the other side. And the next device is LVP5421. As you can see in block diagram, that's a MUX device. It chooses TX1 versus TX2, as well as provide redriver function. The next device is 5412, which is a DMUX function that basically deliver a set of TX signals. In this particular case, 4 differential pair to either to RX1 or RX2. For a PCI Express link muxing or demuxing, you typically need this as pair. You need both 5421, 5412, one for transmit channel, one for receive channel, depending on your application. The last device I'm showing here is PR822, which is a crosspoint device that can offer the connection flexibility to take TX1 signal and provide to RX1 and TX2 to RX2, or it can basically cross as well, TX1 to RX2 or TX2 to RX1, along with redriver signal conditioning performance. So these are all linear redriver products, designed for 32 gigabit per second data rate, suited for PCI Express Gen 5, 32 gig CXL, and UPI applications. As Connie mentioned earlier, I mean, these are linear redrivers. They are mostly protocol agnostic. So you can use these redrivers for other interfaces as well. We do have some PCI specific simple protocol implementations such as RX detect that can be disabled, and it can be converted to any of these devices, can be converted to a simple equalizer with redriver functionality. The device has a CTLE boost or linear equalization boost of 24 dB at 16 gigahertz. And that 24 dB you can choose somewhere from 4 dB to 24 dB with 20 different steps that we have available. And the device you can configure through including choosing equalization through pin strap, an I2C or I2C external controller, or you can read the settings from a WPROM device on board. The device has a very low latency of 100 picosecond or 0.1 nanosecond, compared to multi-nanosecond, when you are planning on a retimer. The device has excellent return loss performance and also very low random jitter addition from the device. By the way, these are all released devices, and on the bottom you can see the link for TI.com, landing page. You can find data sheets or other documentation that can give you a lot more detail about these devices if you plan to use. Another great feature of this device is a single power supply 3.3. The advantage of it is that PCI Express link has 3.3 volt power supply available. A host system provides that power through the interface, CAM interface. So you can use that particular power supply without any additional power component on your board, whether it's a riser card, endpoint, or system board. It has a very low power consumption, 160 milliwatt per channel. One of the great thing about this family of redriver is that if your ambient temperature range of your end equipment or system is minus 42 degree to 85 degrees C, you would not need any additional thermal solution on board, such as you do not need heatsink, for these redriver products in your application. So, redrivers are typically a very effective, low power, low latency, and low cost alternative to retimers. We do have some great features as well. Please let us know if you have interest. We can engage and answer your questions down the road. Next slide. So this particular slide showcases how our PCI Express Gen 5 redriver can provide a reach extension. The purpose of a redriver is to basically help in a link where your loss is more than what PCI Express link inherently capable of. That also varies system to system and different kinds of link impairments you have. But typically it's about 36 dB or so. So on top left corner, I have a table where two columns shows one without redriver, another with redriver with no dot and with dot columns. As you can see, when you are not using a redriver, this particular setup where we have a lead server platform with PCI Express Gen 5 enabled. The total link we were able to get is 34 dB for a I diagram of 11 picosecond and 31 millivolt at 1 e to the power minus 12 bit rate. So fundamentally, without redriver is about 34 dB. Same link. What we did is we added some more loss cards in the link. And as you can see, we are able to get almost identical I diagram with almost identical eye-opening numbers, 10 picosecond and 29 millivolt, for a 53 dB of link loss. For this particular illustration, we are showing that this redriver can extend 19 dB of reach, beyond what PCI Express Gen 5 inherent link is capable of. And depending on situation, that reach extension can change. Nominally, our redriver portfolio can give you, 24 dB over PVT is about 50% more rich compared to PCI Express Gen 5 link, which is an additional 18 dB reach extension. Next slide. So this showcase similar things, but here what we did is instead of a test equipment as a receiver to figure out the eye opening, here we are doing a functionality test. So we have again a lead server platform as the root complex, and a lead PCI Express Gen 5 switch as an endpoint. And we are establishing a link between that root complex and endpoint, with and without redriver. So first two lines are without redriver. So as you can see, we were able to establish a link for 35 dB of loss, for 1E2 minus 12 bit rate, but failed a link for 39.3. So inherently, it is capable of doing something in between 35 dB and 39 dB. I mean, 36 dB is typical the link that PCI Express Gen 5 can do. Now, what we did is we added additional loss before our and we added a redriver on the link as a riser card, and we added loss before the redriver and after the redriver using loss card, flag card. We are line number 4 to 8 represents those 3 to 8 represents those combinations. So as you can see, 57 dB successful link, 66 yes, 70 is not, and 50, 57, and 64 is also successful with different combinations. So we are able to provide a successful link, Gen 5 link, somewhere in between 66 to 70 dB. So it's quite a bit rich extension in a functional mode this redriver is capable of providing. Next slide. So this is a receiver lane margining test. This is a critical test that many of our OEM partners perform. In this particular case, we have a setup where again we have that lead server platform. And this testing was actually done by that server chipset vendor in their lab. This particular link is about 51 dB, more or less. They have performed a lane margining test for all 16 lanes. As you can see, they are able to pass lane margining test for both vertical and horizontal, for all these lanes for this particular link. Next slide. So this shows a transmit compliance test setup. So we have done this in our lab. This is again a Gen 5 enable server platform with our redriver, inserted into the CAM connector, and then PCI-SIG, test fixtures, for compliance setup, and a PCI Gen 5 enable scope to run the SIG test and to report pass fail. So what we are seeing here is on the right that we are able to pass a link, and one thing to note is that the transmitter, root complex transmitter, they have option of this different transmit EQ 0 to 9, 10 different transmit EQ. We are able to pass for all. It is not required, but for this particular setup, we are able to pass for all transmit EQ. Next slide. So this particular slide showcases that I made we have a redriver portfolio, 8-channel redriver, 4-channel redriver mux demux, and we have done testing at PCI-SIG Plugfest and in our lab. We had opportunity to actually link it up with many different host platform or root complex platform. Number of endpoint that we have access to is very limited. We had Broadcom switch as an endpoint and as well as an endpoint. And we also had a Samsung SSD as an endpoint. And all the endpoints that we could get our hands to and host, we can get our hands to, we were able to successfully create a PCI Gen 5 link. So what it demonstrates that the redrivers, when it is in the PCI link, can successfully interop between different host platforms and different endpoints. And our Gen 4 products that we have released a while back, we have done testing a lot more number of combinations, and we are happy to report that our redriver can successfully exist in a link without any issue. So that's the purpose of what we are trying to show here. Next slide. So as you know, I mean, be able to interop with the ecosystem is very, very critical. And PCI-SIG has they maintain a integrators list. What they do is they actually pair up with number of different combinations of host or root complex and endpoint. So they, a part of that is many interoperability tests, as well as some electrical testing for test the receiver and transmitter performance. And once everything passes, they actually approve a specific silicon component or system for integrators list. We are happy to report that we have PCI Express Gen 3. Gen 4 and Gen 5 redriver that successfully completed the integrators list test procedures in Plugfest. So and we are actually only silicon vendor that we consistently passed PCI-SIG Plugfest testing to appear in the integrators list. And this link you can click and see the components that we have in the integrators list, and not many actually other is able to pass that compliance, and it is probably very important confidence building element for you to use TI redrivers. Connie?
Thank you, Anwar. I just want to quickly conclude with some of the resources that we have. If you're interested in learning more about our redriver and testing our Gen 5 redriver, as well as any tools that you may need, we do have a DS320PR810 EVM that's available. This supports a by 16 or 16 lane setup. It comes with a CAN connector, so you can easily plug into your system between the root complex and the endpoint for evaluation for the performance. In some of the collateral that we have for this device bring up is we have a configuration guide, Python API, and if you want to understand the performance prior to designing the board, we also provide IBIS AMI and S parameter model for any type of simulation, schematic layout design guide. We also are very active on our E2E technical support forum, where our application teams support customers directly on this forum if you have any questions regarding our PCIe portfolio. And all of our EVM or evaluation model does come with a graphical user interface that allow you to fine-tune your redriver easily with quick adjustment and buttons to adjust the CTLE equalization, the gain that can quickly configure to your evaluation module. And if you never designed with redrivers before and would like to understand more, just in general, how to implement redriver and how it compares to retimers, we do have a technical article on the bottom, also have a hyperlink to it, that kind of go over some of the questions revolving PCIe redriver. It goes over tips and tricks in fine-tuning redriver, running simulations, its performance, and how it compares to retimer and how it can support your overall signal integrity. With that, that concludes our presentation today.
Thank you, Connie, and thank you for attending today's NPU webinar. The recording and PDF version of the slides will be available at ti.com/NPU. See you next week for our next topic, the industry's first camera ultrasonic lens cleaning chipset. Have a great day.
Thanks, everyone.
Thank you.
Thank you.